Support for Central Florida Public Media comes from the University of Central Florida, offering their Masters of Science in Data Analytics program. Designed to enhance skills in data analysis and machine learning, the new Artificial Intelligence track offers specialized courses to deepen understanding of AI technologies and their applications. More at ce.ucf.edu/data.
Listening to the cosmos and cooking up a space menu, you're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. Some things in the universe we just can't see through visible light. So instead, astronomers rely on radio waves.
You can just kick those radio waves out and be like, right, I'm going to see what Venus is up to today, boing.
We'll speak with astrophysicist Emma Chapman, author of the new book, The Echoing Universe, How Radio Astronomy Helps Us See the Invisible Cosmos. Then, meal prepping for a space mission. From trips to the International Space Station to flybys around the moon, there's a lot that goes into meal prepping for crews that leave the planet, including taste and dietary needs. We'll speak with NASA scientist Ryan Dowdy about how food is selected for space missions. That's ahead on Are We There Yet? Sometimes you can't always see what you're looking for in the universe. That's where radio astronomy comes in. These astronomers listen for cosmic radio waves and beam out some of their own to find things that would otherwise be hidden. Here to talk more about radio astronomy is Emma Chapman. She's an astrophysicist and author of the new book, The Echoing Universe, How Radio Astronomy Helps Us See the Invisible Cosmos. Emma, welcome to Are We There Yet?
Thank you very much for having me. I'm excited to talk.
Yes, it's a very exciting topic, and the book takes a deep dive into radio astronomy. But I'm going to start with a simple question with a very complex answer. What is radio astronomy, and why do we care about it?
Okay, radio astronomy is communicating with the universe. That's it. That's your simple answer. It's being able to look up and see not just in the optical wavelengths that our eyes have evolved to see, but actually a much kind of wider range of light. But that's all it is. It's just a different wavelength of light, but the same kind of stuff and new stories.
How do you detect these radio signals? So essentially, how do you practice radio astronomy?
Yeah, well, you need a different kind of eye. Our eyes have evolved very specifically to a very, very narrow, very, very small wavelength of light. You can kind of imagine kicking your legs in the water, like hanging your legs over a pier or something, kicking your legs. You're kicking your legs really, really fast. You've got really short wavelength waves and like lots and lots and lots and lots of ripples. That's kind of the light that our eyes have evolved to see, which is why our eyes are nice and compact. But when you want to see something much longer wavelength, really slow kicking now, nice long wavelengths, you need a much larger eye. And actually the way we do that is using antennas and dishes. So this is equipment that everybody above a certain age will definitely be familiar with, because they'll have it rusting on the side of their house from times that we only had, satellite TV or things like that. Or we had radio antennas on our car. I don't know if you ever had one of those where you had to but even in your pocket, you're always carrying around a miniaturized radio antenna in your phone. And that's what's picking up all these radio signals. So that's what we use, what looks like quite old technology, but behind it, there's some seriously complex kind of computational work going on, and translation, actually. Just like your eye is translating the light coming into it into an electrical signal into your brain that's then being interpreted as, oh, I see all I can think of is a green rabbit. That's really weird. I find it fascinating when you put it on the spot like that, oh, I've seen a green rabbit or whatever. But with radio light that comes into the antenna, it's an electrical signal just the same. And we have to do a bit of translation so that it's something that we understand. I think of it as like a paint by numbers. You can imagine if you're looking at, let's say, the galaxy, then you can get a paint by numbers where 1 is red, 3 is blue. All we do is say, okay, a wavelength of 2 meters, let's call that red. And we do that, and we can fill in our paint by numbers. And then the bigger the telescope, the more detail in your paint by numbers.
I know that, here on Earth, we're emitting radio signals. The show gets emitted via transmitter once a week. But are like planets and stars and all these things, they emit some sort of radio wave that you can pick up on?
Yeah, they do. And there's two kind of elements to radio astronomy. There's the listening element, which is when we do just listen to, for example, pulsars, which are spinning stellar remnants, which like pulsate with radio. Like we can hear those if we just listen, as in if we just kind of almost listen with our eyes, if you will. If we look at it, use an optical telescope, we're just receiving that light. The other part of radio astronomy that I love is that way more active. And that's when we can actually send out radio waves, bounce them off stuff, whether it's asteroids or the surface of Venus or Mercury, and then they echo back, they return back to us, this radar, and then we can work out from how long those waves have been away, loads of stuff about loads of really local things in our solar system.
That's fascinating. So it's almost like, a kind of a radar gun that the cops would use, right? You can tell something by how long it takes for that to bounce back.
It's exactly the same technology.
What are you finding out if you like beam one of these radio signals at, let's say, a near Earth asteroid?
Okay, so a near-Earth asteroid, it tells you instantly what direction it's going, whether it's going away from you or towards you, which is really important when you're looking at an asteroid. Now, optically, you can tell that as well over time. You can photograph it every night and you can watch it going across the sky. And basically, is it getting bigger or smaller? But if it's, for example, coming from the sun's direction, you can't do that. And you can lose it as well. But with radio, you get that information straight away in minutes or seconds. So it's very, very handy. And we've used that for planets to work out how quickly Venus is rotating, so the length of its day and how that is changing over time. For a long time, it was actually the way that we defined the distance to the sun was this astronomical unit that we use, where like the Earth is one astronomical unit from the sun because we can't be bothered with all of the hundreds of millions of kilometers or whatever. And we worked that out so precisely by pointing a radar gun at Venus.
Fascinating. That's so cool.
It's unexpected, isn't it? Don't you think it's unexpected? You think you're going to be like listening. And this is the element of radio astronomy that I really like emphasizing to people, because we're kind of used to, with James Webb, other wavelengths of light, like infrared light. Okay, we're going to look in infrared light. And that's awesome. We can do loads of stuff in the radio with that. But radio is the only one where you can do this really active form of astronomy. So much of astronomy is sitting there and waiting and hoping the thing that you want to explode explodes. Whereas with radar astronomy or radio astronomy, you can just kick those radio waves out and be like, right, I'm going to see what Venus is up to today, boing, and I can just have some fun with it. I love that.
You're listening to Are We There Yet from Central Florida Public Media. I'm Brendan Byrne. We're speaking with Emma Chapman. She is an astrophysicist and the author of the new book, The Echoing Universe: How Radio Astronomy Helps Us See the Invisible Cosmos. You mentioned essentially one form of radio astronomy is shooting a radar into the night sky and seeing what you pick up and bouncing back. Are there limits to how fast these radio waves go? Do they travel at the speed of light?
So they travel at the speed of light. They're just light, like every other kind of light. They travel at that cosmic speed limit, and just like every other kind of light, if you've switched on your flashlight, then it might be really bright close by, but it's going to fade out over distance quite quickly. Same with radio light. So we can only do this kind of active form of radio astronomy to about Saturn. But there's some incredible images online that kind of look at the same time underwhelming and also amazing, which are of the rings of Saturn in radar. And they've reflected radio light off the icy grains, but the actual planet is not there because it's absorbed all the radio light. So all you see is like this fuzzy ring. And like, it's fairly useless for science. I'm not going to lie when you get to that distance, but like everything before that's really cool. But like the Saturn stuff's a bit like just for fun. But my God, like being able to reach Saturn from Earth, I should say as well. This is just from, like just radio telescopes on Earth.
Emma, you mentioned, with those kind of short observations, we can tell things like, the rotational speed of Venus, as you mentioned earlier. But as you write about in this book, radio astronomy can also help discover exoplanets. Is that through listening, and how are those observations made?
Yeah, so it was actually the first ever exoplanet was found using radio telescopes, which is fun because they found it around a pulsar, which I would describe as this spinning stellar remnant, a dying star. It gets really, really collapsed and dense and spins very, very fast, and it creates these jets of radio light. And they're like lighthouse beams. And what can happen is that it's a very, very precise spinning of this star. So it's almost like is to the level of like an atomic clock kind of accuracy. If you've got a planet around that pulsar, then it just slightly disturbs that timing. It just slightly jitters it. And you can tell with like how long that jittering takes, like how long it's affected, like whether the planet around it is orbiting at this kind of distance, how massive it is. And so that's how they found the first ever exoplanet. It was just less interesting than the one they later found, which was around a sun-like star, because you can't survive near a pulsar. And we kind of only really care about exoplanets a lot of the time because we want to know if they've got life.
Emma, I'm thinking of kind of other telescopes, like the James Webb Space Telescope, which is in space, and that's infrared, and there's Hubble, which is optical light. Are there radio telescopes in space? Is that a good application for them?
Yeah, there's plenty. There's every space mission that you've ever heard of has pretty much been using a radio antenna to communicate its data back. There's some kind of laser communication as well, but if it's a cloudy day near wherever NASA's receiving it on Earth, then your luck's gone. But radio waves have a superpower, which is being able to slip through the atmosphere almost unperturbed, which is what makes them wonderful for so much communication on Earth. And so, yeah, you have the radio telescopes all over, like Voyager, I would say is, one kind, because it's using these radio antennas to explore. But you've also got the new missions that are very much hoping to land like everybody else on the planet, on the far side of the moon, and land some antennas down and do some research into kind of the cosmological side of the universe.
So certainly some really interesting use cases for radio astronomy. Emma, finally, with the new book coming out, The Echoing Universe, what do you hope readers take away about this type of astronomy? What do you want them to go home with after reading this book?
I want them to feel wonder, and I want them to feel, oh, that's cool. And like, even if they only remember that for 10 minutes and get to tell one person who's in their kitchen who doesn't really care, that's enough for me. And then like, I want them next time they see a story in the newspaper that's got something to do with radio astronomy, don't want them to be scared anymore, because I find that people are really off-put by the term radio astronomy. And so the whole aim of this book is like, you know what, get through the book. I hope you have a laugh while you're reading it, and it just breaks down some barriers. And that's the aim.
And maybe some extraterrestrial astronomer who is studying radio astronomy will hear this conversation and take that away from your book as well.
I hope so. It'll be 70 years or something, but whatever.
Yeah.
They're quite possibly out there listening. So
we've been speaking with Emma Chapman. She's an astrophysicist and the author of the new book, The Echoing Universe: How Radio Astronomy Helps Us See the Invisible Cosmos. Emma, thank you so much for joining us.
Thank you very much.
Still to come, food in space isn't just for nutrition. It can also remind astronauts of home.
Food needs to be a psychological comfort as opposed to a psychological stretch.
The role of food in exploration, that's ahead on Are We There Yet? You're listening to Are We There Yet? From Central Florida Public Media. I'm Brendan Byrne. Imagine if scientists could discover thousands of new exoplanets and study dark matter. Well, with the Nancy Grace Roman Space Telescope, that could soon be a reality. Once it launches, it will study our universe about 1,000 times faster than the Hubble telescope can. We'll talk about this new telescope launching on a future episode of Are We There Yet? But for now, we're talking about food and how everyone, even astronauts, got to eat. A lot goes into the meal planning and selection process for astronauts.
The Artemis 2 crew had direct input into the food that they have available during the flight. They were able to sample and rate all of the foods on the menu, and their preferences were balanced with the nutritional requirements needed and what Orion can accommodate.
Food for space missions is carefully selected for each trip, with attention to nutrition and comfort, too. We spoke with Ryan Dowdy last week on Are We There Yet about space food. He's a NASA scientist and founder and CEO at ReadyBar. Here's more from that conversation now. I'm stuck on this scale, this 1 to 9 scale. It doesn't fly unless it's over 6. Was there anything that you developed that you were like, this is going to be a hit? And the astronauts were just like, Ryan, this is terrible. This is a 3. We're not flying with it.
Yeah, one of the big challenges that I saw at NASA was when product ideation started with the food scientists instead of actually starting with the customers. So when you're working in NASA, you're working in the food lab, your customers are the astronauts. You're not catering to the American public, you're catering to the 4 astronauts that are in space at any given time. And we developed a meal replacement bar that was jalapeno walnut flavored. And we said, you know what? We think savory bars are going to be a big hit because you don't have to put as much sugar in them as a sweet flavored protein bar, right? So we started developing a few savory bars, and we thought, jalapeno walnut's probably going to do pretty well at it. That sounds fun. It's sweet and savory. It's got a little heat, a little spice. Astronauts tried it. They hated it. And so I think part of the issue that I found there was that if it's not a flavor that people are expecting or used to, that even though it sounds good, in execution, it might not turn out really well. And so the issue there was that, people weren't used to a jalapeno walnut flavored protein bar. And when crew members are in space, they're not necessarily looking for new flavors. Food isn't the food isn't used as like, hey, let me try 50 different flavors that I've never tried before and see if I like it. The thing is, astronauts are doing 50 different science experiments a day that they've never tried before, and they got to have an EVA the next day that they're prepping for. And so food needs to be a psychological comfort as opposed to a psychological stretch. And so that comfort aspect was funny. The jalapeno walnut didn't end up making it into production. And it's something that I've done with ReadyBar is I've realized that, instead of focusing on inventing new flavors that people haven't tried before, what I've tried to do is bring flavors that people are familiar and comfortable with and create nutrition that people aren't getting elsewhere.
I do want to talk about your work at ReadyBar, but I got one more question about cooking for astronauts, preparing food for astronauts. We've had an opportunity to talk to quite a few astronauts on this show, and the conversation always turns into food, right? And one of the more surprising things that I learned from the astronauts is their taste buds change when they are in microgravity. And they really liked something like shrimp cocktail because it was spicy. There was that horseradish in there. It was a very punchy flavor. Do you take feedback from the food that has flown in space? Because if you've got this system to design food and their astronauts are testing on the ground, their mouths are much different in space, right? How does that play into what you design and how you design a food menu?
Absolutely. After every mission that flew, I would meet with the astronauts and get their feedback on the food system. So they tried the food and gave us feedback while they were on Earth, and then they ate the food in space and they gave us feedback after they got back. And you're right, since this change in space, there's a fluid shift. The fluid that's normally being pulled down towards your feet by gravity is now up in your head, and it fills up your sinus cavities. You can't smell. And 70% of the flavor of food actually comes from your nose detecting the aromas that are rising from your mouth. So suddenly you've lost 70% of your ability to sense food in space. And so that's why horseradish, hot sauce, and pepper, these are all compounds that actually interact directly with your tongue. You don't have to smell hot sauce to know it's spicy. It's your tongue that senses it, and your tongue sends that nerve chain straight to your brain. You know it's spicy, you know it's good, and that's why they like it so much. So that absolutely played into how we designed foods. And, Artemis 2 took 5 different hot sauces with them. And hot sauce is a huge part of space food culture.
Yeah. And it's also very personal, too, because I could see them each having their own different brand of hot sauce as well that they want to take up there, right? I mean, it's very close to your identity,
Everybody likes different stuff. And it was funny. A lot of people started requesting sriracha hot sauce while I was there. So we started flying a lot of sriracha in the fresh food kits. Is they would say, hey, we're out of, we know you're sending us apples and oranges. Can we get some more sriracha too? Because we need we're making sandwiches with our wraps with our tortillas. Want a little more spice on there. So we started sending up a lot of sriracha.
I'm a crystal guy, but that's no endorsement. That's just my my personal thing there. So, Ryan, I want to talk a bit about how this, so much work and so much effort goes into making this menu for astronauts here, but NASA is the products that come from NASA technology are a lot of spinoffs that we can use down here on Earth. How are some ways that scientists like yourself are taking what you learn about preparing foods for astronauts in space and bringing it down to Earth and giving it to people like me?
That's one of the most fun things about the work that the Food Lab does, is that there's a lot of application to Earth. And the biggest learnings that I had at NASA were that the more omega-3s and antioxidants that we can put into our food, but it shouldn't look like space food, remember? It shouldn't look like tubes and cubes. It should look like real food. And I realized that we can apply that same thing here on Earth. So I started a company called Ready Bar. And the idea is you take the meal replacement bars that we were making for astronauts full of omega-3s and antioxidants, but instead of trying to make weird or new flavors, you just make flavors that people love, like peanut butter and jelly. So we make a peanut butter and jelly bar that's 3 layers, looks and tastes exactly like a peanut butter and jelly sandwich. But guess what? You don't have to refrigerate it, and it stays shelf stable in your backpack or in your car for 2 years. And it's full of omega-3s and antioxidants. So it's perfect for busy parents, people who are in a recording studio for 12 hours a day and they don't have time to prep a lunch. There's so much applicability from what we've learned keeping humans alive for 6 months at a time in space in terms of how we can feed people here on Earth, that the sky is the limit when it comes to finding innovations that we can really have a lot of fun with here on Earth.
You're listening to Are We There Yet?, the radio show exploring space exploration. I'm Brendan Byrne. We're speaking with Ryan Dowdy. He's a NASA scientist and founder and CEO at Ready Bar about how food is selected for space missions. Is there a jalapeno walnut bar? Because I'm intrigued. I want to try that now.
I know it sounds really interesting, but here's the thing. Whenever we've sampled savory bars to people, they would say, I am never going to buy a product from you. And then when I sample the peanut butter and jelly bar to them, they say, I will buy every bar that you have. So we came out, our first flavor was actually a savory flavor. It was called the 5-Alarm Chili Bar. And it was essentially a protein bar that was made of compressed pinto beans with 5 different types of chili peppers in there. And, we tried this and everyone was like, ooh, that sounds so interesting. And then they tried it and they say, I don't want anything to do with you. I'm going to forget I ever met you. This is an awful product. And so at some, every once in a while on April Fool's Day, we'll release that we're, redoing the 5-Alarm Chili Bar, and people get really excited about it. But it's just, it just doesn't work. It doesn't work.
All right. Well, you've convinced me not to have it. Finally, Ryan, the work that you did on the International Space Station, the Artemis missions, you brought it to the commercial world. Things are changing when it comes to space exploration as well. We're seeing plans for commercial space stations, commercial space astronauts. They are going to need their own space food. Is there a market in the commercial sector to be providing food for these new stations?
There's definitely a market for providing food for commercial spaceflight providers. One of the big issues that we're seeing is that NASA isn't set up to sell food to commercial entities. There's not really a legal or, any sort of economic method for that to happen. And on top of that, the Food Lab is really only set up to make enough space food to feed the astronauts that are on the International Space Station. They're not set up to quadruple that production and sell that food to commercial spaceflight providers. And that's where a company like ReadyBar steps in. ReadyBar is able to provide those products as a commercial off-the-shelf solution so that commercial spaceflight providers can add a product to their menu that has the shelf life that they want, that has the score of 6 or higher. And it's, NASA has flown these meal replacement bars and our customers love them. So I think there is a market and it's going to continue to grow. And I'm excited to see that.
I know I said that was the final question, but I got one more for you, Ryan, before I let you go. Of all the foods you developed for the NASA space program, what's your favorite?
My favorite food that we ever developed for the ISS menu is really surprising. It's black coffee. And there wasn't a lot of development for it. But what was funny was it took a lot of time to actually convince everyone that we should have black coffee standardized in every single container of food that we sent to the ISS. Because everyone was worried, hey, some people like with cream, some people like with sugar, some people want equal sweetener, blah, blah, blah. No one could agree. But we looked at the data over the last 20 years of consumption on the ISS. And do you know what the single drink is that every single astronaut consumes? Black coffee, you got it. And so we added it to the menu. And I was so happy because once we added that to the menu, it actually helped kick the astronauts into even higher gear because they're high performers. They run marathons in space, for crying out loud. So they love their caffeine. And I was so happy that we got black coffee on the menu. And I'm glad it made it onto Artemis 2 also.
Black coffee for astronauts, they would do well in a newsroom because that's really all that we drink as well. So good to know. We've been speaking with Ryan Dowdy. He is a NASA scientist and founder and CEO at ReadyBar. Ryan, thanks so much for chatting with us.
Thanks, Brendan.
That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts, Spotify, or wherever you get your podcasts. Stay connected with this show. Be sure to follow us on social media. You can find us on Instagram and Facebook. We're at AWTY Space. And if you got an idea for a future episode of this show, or you want to join us as a guest, reach out. Our email is arewethereyet@cfpublic.org. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Editorial guidance from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.